All right, guys, so we're going to continue with the parametric functions or equations that we were doing the other day, but we're going to look at the applications. There's a lot of applications, especially in terms of motion and physics-related problems when you're dealing with parametric, but we're just really going to talk about a specific one, which is projectile motion. Okay, and you've probably done motion before where you found the height of an object after time due to gravity, and that's going to be part of the model that we do in this one. So the idea of projectile motion is that you're tracking two positions of the particle, not just one. Okay, so we've done motion before when we've had h of t or x of t, but really you're just calculating one position over time, which is called rectilinear motion. All right, when you're trying to model a path of a particle, then this is curvilinear motion. All right. So the type of problems that we're going to do today with the projectile is when an object is propelled upward at an angle of theta. So instead of just being thrown up or down directly, which is probably the ones you've done before in physics, the particle is going to be at an angle to the horizontal with an initial speed we're going to call v sub 0. Initial height will also be in there. That's going to be h sub 0. And the resulting motion would be the projectile motion. So we're going to be able to track the height and the horizontal position of the particle over time. So there's a very simple model that we're going to use. So it's just we're going to plug in values given a certain problem. So our model is going to look like this. Okay, so it's parametric because we've got x equals and y equals. All right, so two dependent variables where the independent variable is t. V sub 0 is the initial velocity of the object, and then theta is the angle at which the object is traveling when it's released. And g here, which it says at the bottom, is the constant acceleration due to gravity. And there's two different values you could use. We're going to do a lot of problems in terms of feet or feet per second. So we're going to use 32 for g. So -1/2 times 32, that's going to give us -16t squared, where in a physics class, you tend to use more meters per second. So 9.8 is acceleration due to gravity in meters per second squared. So when you plug that in here, you end up with -1/2 times 9.8 is -4.9t squared. All right, so that's the one you might be used to seeing in a physics class. And again, y is given the height of the object, the y position, where x is giving you the horizontal position of the particle. And the theta value, we're going to do that in degrees. So we're just going to make sure that we're in degree mode when we're doing that. And h sub 0 is the initial height of the object. Okay, so if it's on the ground, it starts at initial height of 0, but if it starts above the ground, then we have to plug in our constant there. So the first problem that we're going to look at, and we're going to solve it on the calculator, and we're going to do it algebraically. So let me just put the problem up, and then on the next video, we'll go through the two ways of solving. So for example, the right field fence at Fenway Park is 4 feet high and 310 feet from home plate. Dustin Pedroia hits the ball at a point 2 feet above the ground and leaves the bat at a speed of 108 feet per second at an angle of 30 degrees. All right. So this is giving us all the information we need to set up the system of parametric functions. And then there's going to be a question asked. This says to graph the path of the baseball. And then is the hit a home run? So assuming that nobody's catching the ball, will the ball clear the fence? All right, that's basically what we're being asked here is will the ball clear the fence? So we're going to look at this in two different ways. We're going to solve it on the calculator because it also asks us to graph it. So that's the first thing we're going to do is show how to use the calculator to solve the question. And then we'll show how to solve it algebraically.